All right. So we have used Pythagorean theorem to solve for a missing side of a right triangle, and that's when you're given two sides. That's when you're given two sides of the triangle. So when you're given two sides of the triangle, you can use Pythagorean, and it'll help you solve for the third missing side. But sometimes you're only given one side, and you're given an angle, and it wants you to find a side, and that's where our trig ratios are going to come back. Okay, so we've talked about trig ratios also. We've set them up. We haven't solved them, but we've set them up, okay? So today we're actually going to solve using trig ratios. So we have our sine. We have our sine theta. Theta is just the angle that you're using, okay? Remember I told you can use angle A or B. All right, they're going to give you an angle, and you've got to use that one, or sometimes they'll give you two, and you can choose which one you use. So sine theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent, okay? We're going to use these three formulas to help us solve our triangles today. Now, the big kicker is your calculator has to be in degree mode. All right, I'm going to show you in this video how to put Desmos in degree mode, and then I'll have to send you a separate one that shows you how to put your TI-83 if you want to use a TI-83. It doesn't matter which one. I'm going to be using Desmos because it's what you can see on my screen, okay? All right, so there are steps into solving this, okay? I like these steps because it helps you also figure out, because the biggest question I have with trig is how you know which formula to choose. That's one of your biggest problems. Like, how do I know if I choose sine? How do I know if I choose cosine? How do I know if you choose tangent? Well, if you follow these steps, it's going to tell you which ones to use, okay? So, steps. All right? Step 1, you're going to label hypotenuse first. Only if it is not blank. If it's blank, you do not label it. Hypotenuse. Remember, hypotenuse is across from the box. So this is my hypotenuse. It's blank. So guess what? We're not going to label it because it's blank. All right, so we're going to skip hypotenuse. Now, the next thing you do is you circle your angle. Circle whichever angle you want to use. Circle angle to be used, okay? Here they always give us the one. We know we can find the other one because we know all three out to 180, but let's just keep it easy. So we're going to use 28 as our angle, okay? We have to circle our angle because remember I told you earlier, the angle is what chooses your opposite and adjacent. So step 3, you're going to label opposite it only if it is not blank. Opposite, I told you opposite is the one side, the only side that does not touch your angle. So it's the only side opposite to the angle you circle. So this is my opposite, and it's not blank, so we're going to label it, okay? And then last but not least, you label adjacent, okay? So we're going to label adjacent only if it is not blank. Adjacent is going to be the side that touches it that's not the hypotenuse. Well, this side touches 28, and it's not blank, so it's adjacent. And that's how you choose. And now we know that the formula we have to use has to include adjacent and opposite. So we come up here, and the one that includes adjacent and opposite is going to be our tan. So that's the formula we're going to use. We're going to use tan theta, which is opposite over adjacent, okay? Theta is the angle that you circled. So theta is going to be 28. So we're going to say tan of 28 equals opposite. Opposite's x. Adjacent's 32. Your first step is always in this one. It's always, okay? It is always to multiply by that denominator. I don't care who that denominator is, you're going to multiply by it. So now I have 32 times tan of 28 equals x. Is x by itself? It sure is. So we're going to type this into our calculator right here. This guy right here. Whoops. All right. It's interrupted. We're going to type in this 32. Whoops. Where'd it go? Oh, eraser. Okay. So we're going to type this into our calculator. Okay? We're going to type this into our calculator. All right? Maybe my Apple Pen will last. All right, so when we type that into our calculator, now I told you I was going to show you how to put it in degree mode, okay? So to put it in degree mode, you got to come over here and you got to hit this little wrench over here. See how it says radians and degrees down here? Hit degrees. So now I can type this in. 32. Your trig functions are in functions. We're going to go to tan because that's who we used. Type 28 in there, and that's my answer. X. X equals 17.01. Okay? Alright, and that's how we're going to solve all these. Alright? The only thing that's going to change is which trig ratio you use. Okay? Alright, number 2. Okay, step 1, label hypotenuse. Alright, hypotenuse is not blank, so we're going to label it. Circle your angle. Opposite. Opposite's blank, so we leave it alone. 15 is adjacent. It's the only one left. So adjacent and hypotenuse is going to be your cosine. Okay? So we're going to use cosine theta equals adjacent over hypotenuse. Whoops, I didn't mean to do that. I meant to actually write those words. My bad, guys. It's going to be adjacent over hypotenuse. Okay? Your theta is the angle you circle. So we're going to say cosine of 64 equals adjacent over hypotenuse. I told you, I don't care where your x is. Your x can be on top, x can be on bottom. You can never multiply by the numerator. You always have to multiply by the denominator to get rid of a fraction. So we're going to multiply by x on both sides. That cancels my x out over here. Now I have x cosine of 64 equals 15. Now, x is not by itself, but that's fine. This is just one extra step you're going to have to do for these. You have to divide by the trig function and its angle. Okay, the angle always comes with the trig function. So this is canceled. Now that that's canceled, x is going to equal whatever 15 cosine of 64 is divided by. Come over here, type it in. 15 divided by cosine of 64. So x equals 34.22. Okay? All right, let's do another one. Here we go. Label hypotenuse. If it's not blank, it's not blank, so we're going to label hypotenuse. Circle your angle. Opposite, it has somebody. So that means my adjacent is blank. So this is opposite and hypotenuse. I come up here. Opposite and hypotenuse is going to be sine. So we're going to use the sine function here. Sine of theta equals opposite over hypotenuse. Theta is 40. So I'm going to say sine of 40 is equal to opposite over hypotenuse. X is on the denominator again. That's fine. We know we have to multiply by the denominator each time. Cancels. Now I have x sine of 40 is equal to 16. Divide by sine of 40. Cancels. X is going to equal whatever 16 divided by sine of 40 is. So 16 divided by sine, sine of 40. All right, and I told you, functions where your trigs are, okay? We're only using the top 3 in this math class, okay? So my answer is 24.89. Now, always just double check to make sure it didn't throw you out of degree mode. Sometimes the calculator will do that, all right? All right, so 4. Let's keep going, okay? We're going to do a couple more, okay? So, here we go. Hypotenuse. That's hypotenuse. It's got somebody. We're going to label it. Circle your angle, okay? Next, after we circle our angle, we're going to see if we have an opposite. We do not have an opposite, so we squiggle it out. But we do have an adjacent. Hypotenuse and adjacent is cosine, okay? Your angle is theta, which is 33. Adjacent is x, hypotenuse is 19. Multiply by that denominator. So So now I have 19 cosine of 33 is equal to x. X is by itself. Come over here. 19 cosine of 33. So x equals 15.93. Okay? All right. We're going 8. I forgot how many I put down here. All right, so practice makes perfect. All right, hypotenuse. Do we have somebody? We do have somebody, so we label it. Circle your angle. Opposite, it is blank, so we squiggle it out. And this leaves adjacent. Hypotenuse and adjacent is cosine. Okay, it's adjacent over hypotenuse. All right. So we're going to say cosine of 41 is equal to adjacent over hypotenuse. Multiply by the denominator. So when I do that, I get 32 cosine of 41 is equal to x. Type it in here. So x equals 24.15. All right, let's keep going. All right, same steps. You see I'm doing the same steps over and over again, okay? Hypotenuse, it has somebody. Label it. Circle your angle. Opposite has somebody also. So this side is blank. We leave it alone. Opposite and hypotenuse is sine. Okay. Sine theta is 67. Opposite is x. Hypotenuse is 20. Multiply by that denominator. And when I do that, x is by itself. This one's the easy one. Okay. So I come over here. I'm going to type 20 sine of 67. So x equals 18.41. All right. Number 7. All right. Number 7. Okay. Is the hypotenuse there? Yes, we have a hypotenuse. So label it. Circle your angle. Across from an angle, we do have an opposite. We do not have an adjacent. So this is going to be sine theta equals opposite over hypotenuse. All right, so my angle is 45. Opposite is 7 and hypotenuse is x. It always, in these, you're going to multiply by your denominator. So now I have x sine of 45 is equal to 7. Divide by sine of 45. So x is going to equal whatever 7 divided by sine of 45 is. I come over here. 7 divided by sine of 45. Make sure I'm in degrees. Nope, I'm out of degrees. See, sometimes that happens. So let's redo it. Am I in degrees? Yeah. All right.